Okay, I'm going to start with a little bit of an introduction to LIPA. Um, as this webinar is open to the public, I'd like to say a few words about LIPA, especially for the non-members on the call, although most everybody I think is familiar with LIPA to some degree. Um, LIPA was founded in May of 2011 with a very specific purpose, which was to establish a single voice to advocate for laser illuminated projection and its steep task to help update US FDA and global laser safety regulations for this new category of laser containing products. For the past 13 years, yep, a lot of time since then, LIPA members have continued to meet, exchange ideas, update regulations, and educate its member companies and the general public about the benefits of LIPs, laser illuminated projectors, in a wide variety of applications, not cinema where it was originally focused. We're currently seeking to expand our membership. I'll say that with great enthusiasm, as laser illumination has come to dominate nearly all segments of projection and has begun to spread into such diverse applications as automotive, specialty lighting, complex sensing, and remote optical fiber delivered lighting, laser lighting. So a couple of housekeeping items. We'll have a 10 to 15 minute Q&A discussion after the presentation, but feel free to interrupt the speaker politely if you have a clarification question that could benefit the audience in general, such as acronym definitions and so forth. I will say we are a industry association, so we and you should refrain from any questions or discussions that involve specific commercial data or intellectual property. Matt has taken great care to say absolutely as much as he can about the details of the subject and technology without going into any um, proprietary IP or commercial data. So once again, thank you all for coming. I'd like to now introduce our speaker, Matt Johns from Harkness Screens. Matt's been working in the technology side of cinema exhibition for 26 years. Accounts for most of his gray hair, which has allowed a good degree of in-cinema field experience and knowledge, which we'll all be particularly interested in. He's seen a lot of theater screens, and that'll be helpful during the Q&A session. He began his cinema career in 1998, working in technical sales, field service, product evaluations, specializing in something called 35 millimeter cinema automation, which I don't know what that is. Anyway, auditorium light measurement, which is very important to today's topic, and cinema projector, xenon lamps, and control gear. He joined Harkness in 2012 and is currently in the position of Senior VP of Technology Intelligence. We would hope that technology would have some intelligence, um, working as part of the UK-based global technical team. Experience of projection equipment, light sources, 3D systems, particularly important today, screen surfaces and how they can deploy well together in different auditoria has assisted Matt's role with screen technology testing and evaluation, technical training, and quality control and systems. Please welcome Matt for a deep dive into the development and measurement of projection screens optimized for laser illuminated projectors, or LIPs for short. Okay, we'll turn the screen over to Matt and get
Thank you,
started.
Bill. Okay, I'm hopefully sharing a screen. Can you see a
Yeah,
slide there, Bill?
yeah, with print that I can read. That's wonderful.
Perfect. That's what we like to see. So, yeah, thank you all for inviting myself and Harkness to the LIPA presentation. Hopefully some of the information I'm going to try and get across will be useful some of it from a cinema perspective, or for the guys from the cinema industry. But some of what I talk about, I'm sure will have crossovers into other industries, and hopefully there'll be some interest there as well. So without further ado, so first of all, first slide here, what is laser speckle? And I've sort of caveated here in cinema projection. So I think most of us on the call will probably already know what laser speckle is, but for those not familiar, perhaps some people outside of LIPA, from a cinema perspective, or from my perspective, it's an interference pattern that can affect all laser projectors. Some of the things I'll talk about going through, where I mention here to a different degree, will be different types of laser projectors. A lot of people typically assume laser projectors to mean RGB, but of course there are other types as well. And for me, the point of speckle, where we talk about it, where it's a problem, is when it becomes disruptive to the viewing experience. So that's where people are in a movie, watching a film, and they're seeing an effect, which can be an issue. Projector manufacturers, of course, mitigate the effects, and certainly from my time working with digital projection, there's been leaps and bounds from the very early days. There's been the odd step backwards, but on the whole, it's absolutely refreshing how that's moved forward. And of course, some of the PLF or premium large format sort of cinema sometimes use things like vibrating a screen using transducers, which can assist mitigating speckle very well indeed. Of course, being Harkness, we like to think we know about cinema screen surfaces. So the next point there is laser speckle is also influenced by the type of screen surface we're projecting on. And this is very key. It can be very, very different. But one of the things where personally I've got a lot of experience about is what I call visual impact perception. Essentially what we actually see with the naked eye in a cinema. And I will be talking a lot about that. And that covers some of the points here: distance from the screen, brightness levels, types of content, eyewear, which I've noticed very lately now. So, these are things I'll go into. But from a screen perspective, it's not just there's a laser projector, does it speckle, does it not? When we're looking at manufacturing a screen, whether it's with laser speckle in mind or anything else in mind, it's quite a complex process. And there's various factors we have to consider, but it's not just what the Harkness development team needs to consider. We do very much, as I'm sure all manufacturers do, we need to understand what our customer requirements are. So if a customer is looking for a particular property in a screen, or a partner's looking for something, we have to look what we can do in that and what of the other properties will be affected by that. So some of the things we look at, of course, for this call, speckle is something very much in mind with screen surfaces. The gain of the screen, which is essentially a reflectance factor, if you want to call it that, where certain coatings can redirect light in a different way, less diffusing, so more light back into the audience. There's a profile that goes with that, so at certain angles, there can be issues or positives as well. You've got HGA, half gain angle, which is at a position off axis when you get to half of the gain as you start moving off of the center line, essentially. And the position where you get to half is what we call the half gain angle. It's just a useful measurement. Of course, 3D properties, if we're talking particularly polarized silver screens, can the screens maintain a 3D image very well? Contrast is talked about a lot now, and certainly I'll be talking about that a little bit with one of our products coming up. So how, of course, the projector has its own contrast ratios it works at, but of course what you project on makes a difference as well, hence the screen itself. Surface finish, the actual coating on the screen, what does it look like? Is it smooth? Is it rough? What does it do? And finally, mechanical properties of the screen. Is it strong? How much tension? How much weight? These types of things. So it is a very complex process. And it's not as simple as just saying, I want this property, please make it for me. We've got to understand how it all works together, which is what we like to think we do. So what I'm going to go through is to begin with, is our development process itself. So starting from finish, how we look at samples till we finally get to a screen, what we can actually deploy into a cinema. So that process starts with, it could be thousands of samples, literally, and we're looking at all different properties, seeing what can happen. It could be targeted for a particular project, or it could be pure R&D, and we're looking, can we break a particular boundary? So here we're looking at things like coating material selection, the size of any particles we might put in that coating, distribution of that particle. And you can see as an image on the right, which some of you guys will definitely have seen before, which is from one of our silver screen products under a microscope, which is, again, quite an interesting photo to see what's under the hood, so to speak. But then when we get those test formulations, when we pass that stage, we've got to really validate them. And what I mean by validating them is validate them in a proper context that's relevant. So we're talking lab-based, but also field-based. And I'll break that down. So I've got a bar here in the way. That's better. Right. So when I look at this slide here, where we talk about what we've done, our methodology, or what we call our methodology, you'll see later on in the presentation, called Perceptor. It's just how we describe it within the company, is we try to put together all of our knowledge in part of this process to actually to go for a logical process to explain what we do, not only to achieve the product, but then to achieve what our customer wants with that. So when we interpret lots of data, we've got to do it at these stages. And I've broken it down into the 4 stages. So the first stage we'll go through is in the lab, and that's speckle contrast ratio primarily. And I know a lot of you guys on the call I recognize, and I know you'll be familiar with that. At the same time, in the laboratory, we'll visually look at samples. Then we'll move to step 3, where we start to look in our own labs and research facilities, but under movie content with projectors. So be that our own projectors, we might be working with partners, bringing a specific projector model for what we need. And then finally, we move and we really scale up and we move to real cinemas, trusted partners, before we get to launches or trade shows. So let me just move on. That's better. Right. So on step 1, we're actually there in the lab where we look at laser speckle contrast ratio. It's a very important metric, but to me, it tells part of the story, a very important one. But what I try to get across when I talk about people, they might, someone might ask a question, what's the speckle contrast ratio? But people need to understand, and again, looking at a lot of the names on the call, I know a lot of you guys would already, but it's a relative ratio, which to me is very useful in a development scenario. You might be in a lab where you can control all of the equipment, you can control all the distances. So whatever you're testing on that day, whether you're testing as a projector manufacturer, different models of projector, if you're a screen manufacturer testing different screen surfaces with a particular projector, it's relative on that day, but gives you some very useful feedback to how much speckle there might be on a certain surface you're projecting on. But the thing to be important about, which I'll talk quite a bit about, is speckle contrast ratio cannot do what the human eye does, so to speak. So it can't look at viewer distance from the screen. It doesn't look at movie content. It doesn't look at brightness levels. It's a ratio. And it doesn't look at hotspot and position of a projected image. And that's fine. But we just need to understand those differences for those looking at it. So when we then move into that, I look the bit about in the actual cinema is what I've called subjective laser speckle visual impact evaluations. It's a bit of a mouthful, but it's essentially talking about using the human eye, not a camera. And this is where we can look at what's actually happening. And to me, this becomes very important. And it doesn't always correlate directly to speckle contrast ratio. In fact, it usually doesn't. And by the sort of perception factors I look at, one we call speckle depth perception. Essentially, it's the distance from the screen. So the closer you are to the screen, if there's any speckle visible, the more you're going to see that. Anyone used to laser projectors understands that concept. Movie content, the type of movie content, any scene variations. From the most basic, if you're looking at a Star Wars flying around in space with a black background, you probably won't see any speckle. If you're watching Lawrence of Arabia and there is speckle present for a particular projector or in a screen combination, you're going to see that perhaps. Foot Lambert brightness levels, again, very important. If you're projecting at, we use, say, the 2D standard of 14-foot Lambert, DCI standard. If you're looking at an image and you're not seeing much speckle from, say, an RGB projector, if for some reason the customer's running at 25-foot Lamberts because their projector's too large, for example, you may see speckle that you wouldn't normally see at a certain position, and vice versa. Again, very important. And then, of course, hotspot, I put angles and position. Particularly with gain screens, you can have a hotspot, even if it's not directly visible, but it's there if you measure different, and I'll talk a bit about light measurement. But again, different theatre geometries can dictate where the position of that hotspot is, how broad it is, and where it appears in relation to the movie content. And finally, the results are certainly relative to equipment, geometry, and observers. And I'll, again, talk a little bit more about that. So step 1, And again, if I'm going along too fast or anything, and as Bill said, any questions, do feel free to stop me, not a problem. But step one is when we're in our photonics lab. So on the right, you can see an image, and I know some of you will be familiar with such images, which is a camera shot, a close-up essentially of a sample, and you can actually see some speckle on there. It's been measured. So essentially in step one, we're in our lab, we're measuring speckle contrast ratio. We have the samples mounted at 1.3 meters from our speckle maker, which you'll see photos of at the moment, further on in the slide. But it doesn't have to be 1.3 meters. It's a fixed distance that works for us. Again, it's relative. That's our setup. And when we're doing that, we're looking at red, green, blue, and white laser lights. We set the white light at 14-foot Lamberts. It doesn't have to be. Again, it's a ratio. It's just what we do. And if you see some of the results of that here, you can see a set of samples where we've put a baseline in against a matte white surface, and then we've used in this case, we've used our speckle maker, a net cell based unit with a lens. We've taken speckle contrast ratio measurements, and as a relative measurement here, we've compared different samples, RGB, and we're looking at what the performance is. And we can look at that in our early stages of development to see, well, hang on a minute, is this sample worth pursuing? Is there something a bit higher? Is there something a bit lower? We can try and look at trends with different technologies we're working with, but that can be very useful. But again, it's relative. So, you could send the same samples to someone else with similar type of equipment and get a different level of results. That's specifically why I don't put numbers on there, or our scientists don't. So step two is essentially the same part of the process. We're in the lab using the same sorts of samples and A4 samples. For those not from UK or Europe, it's a European, I think it's European, it's certainly UK. It's a UK standard paper sample size, essentially not sample, but essentially a printer paper size. Bill, you did tell me the US equivalent.
8.5 by 11.
That's the one. So it's that type of size we're using. But essentially, when we're at this part of the checking here, at step two, we're still there looking at those samples at the same time as doing the speckle contrast ratio. The team will also be looking visually at the laser speckle on those samples, just for a gauge. Does that look different to the last one? It's not something so much recorded, but it can give an extra bit of insight at times. Step three, and this is where we start to move up. So this is where we might have formulations ready, and we're thinking, well, this one's worth moving up. We think we've got something here with a screen. We'll move up to our internal projection labs. And some of the people on the call have been where this particular one is. And we can move up to our sort of from 5 meters to 12-meter screens in controlled conditions, not in an actual cinema, but with cinema projectors. And what's very useful here, this is then taking it away from the lab and looking visually. So this is here where we're putting white test patterns, we're putting movie content, but we can simulate different geometries. So we can be moving at different distances, different angles, and we get the option to bring in, of course, different partner projectors, different projector types. I mentioned earlier, a lot of people, not necessarily on this call, but sometimes when you talk to end users, they assume laser projector, you're talking RGB. That's a major player, of course, but there's also RB laser phosphor and laser phosphor itself, all to be considered. And when we're doing this again, as well as movie content, we will, of course, look at it under RGB and white test patterns. Again, I find this stage very, very useful, and we can spend a lot of time without influencing a cinema who might be trying to, run shows and have a limited time span. Step four is when we then move up to a real cinema. So we've done good trials in our R&D centres, in our projection labs, and we think we've really got something. We're moving to the next stage. So then we'll move in with trusted partners, anything up to sort of 20-meter screens. And essentially it's the same sort of testing, but also taking on board their input. Not that we think our input is necessarily biased. We have a mix of people around the teams looking at some of this evaluation, but still it's really good to get, third-party feedback. So it's the same thing. We'll be looking at movie content. It might now be specifically movie content that exhibitor or integrator likes to use so they can evaluate it in their own way. But we really are in that real cinema environment now. And again, the projector types could be multiple projectors. Sometimes when we do these trials, it might just be the projector that they've got installed that they might be planning to use, and they want to see it with our particular screen technology. So that's step four itself. But some of you, and I know some of the people on the call have been part of some of these trials where we see the feedback here, but this is subjective, and we have to very much bear that in mind. It's still relative. A particular geometry could give you different feedback, but having a mix of people, we've all got different eyes, we've all got a different subjective appearance, but getting a good crowd together and doing this type of exercise, we often score Speckle from different distances from the screen. You might be able to see a legend on there. We put various legends, things like not visible even if hunted for, barely visible, noticeable, or obvious and distracting. We can move at different distances from the screen and try and log that. You can see in the top right, there's a screenshot. I'll mention that briefly in a following slide, but that's from a HSD Labs Ultimate, which can see 144 points of light. It's not measuring speckle, but it can show very clearly how a particular hotspot or uniformity spread across the screen is actually looking. And of course, in my own experience, particularly now with modern laser projectors, it really is concentrated in the hotspot. Of course, for me anyway, the very early days of 3P RGB, it was speckling across the whole screen. It really was quite severe. But now it seems to be much more concentrated in the hotspot. So it's very useful to understand that. And then we can look at different samples or be using different projectors and grade them all and try and produce data from that. And it forms part of the story alongside the speckle contrast ratio. So just move on the slide. Here we go. And the final summary of just what I've talked through there. If we look at hundreds of units that we might have brought in, we do the lab work first.
Matt,
again. Please, Bill. That was Bill.
Yeah, I don't think your slides are advancing for some reason.
Oh,
I'm still seeing the one with the green guy looking at the laptop and the two meters looking at the screen.
Bear with me. So that's not.
I mean, you were following the 1, 2, 3, 4 steps, but I think you have detailed slides that aren't.
Yes, I have. Yes, there's. Okay. We've got a glitch there. So let me see. So you're still seeing the guy with the green?
Yeah, I think it's slide 2 or 3. But
here we go.
There you go. Okay. You can.
Can you see step 3, step 4?
Yeah, good.
Okay, very quickly, apologies, guys.
No, I'm sorry, I just remembered that from the dry run. Yeah, this is the one that I knew we were missing.
No worries. Okay. So where I was talking about if I just go back a slide, hang on. That's better. I'll just very quickly go through those. So you'd seen this one. So step 3, which was when we were actually in our projection suite, you can see we've got areas gridded off. We can very quickly see different meter distances and angles and so on. Obviously, we move into cinema, and slide doesn't go too much more with the image. And then this one here where we're looking at the feedback. So you can see here we've got different speckle scores. We have different legends we may use depending what we're doing, talking about visibility. We can represent it in different ways when we get the data, straightforward stuff, showing a screen, what we're seeing from different distances and so on. 144-point light readings, so we can understand what we're actually looking from a brightness uniformity perspective, which certainly makes a difference, as I said, to laser speckle. So that's useful to see. But then the summary part on there, which hopefully you're now seeing, still working, Bill? Brilliant, thank you. So step 1, we've got hundreds of samples, but we're doing it actually in the lab, A4 samples. We're testing the gain extinction ratio, which is a part of the 3D component, half gain angle, anything standard screen metrics will we measure. We'll be looking at RGB and white light, but we're not moving to any of the cinema side. Step 2 is essentially the same, but visually. But step 3 is then when we move up to, we're reducing the amount of formulations we're trying, but we'll still have ones there. We move up to 5 to 12 meters. We can still test the screen profiles there using portable equipment or samples afterwards. But this is where we really move into a very important part where we're looking at movie content. And we have to be very realistic with here. We can't just show, let's call it speckle favorable movie content or unfavorable. We've got to be even. So it'll be a combination of content, but including certainly mixed scene. We certainly need to be seeing light content, and certainly not all dark content. That certainly won't help us. And when we're doing this here, as I showed you with 144 points, we'll be looking at hotspots. We'll also be validating mechanical properties, the screen on the frame. And of course, fire testing, when we're deploying screens into the field, we of course have to have them fire tested to meet local regions. And finally, the visual stage in cinema, which is essentially a repeat of step 3, when we're working with trusted partners and customers and getting real world experience, shall we say. Now, I talked a little bit about some of the products we use. I don't mean it as a product pitch, but I just really want to talk about the difference. So on the left is the HSG Labs Ultimate, which is one of our products, but it allows us, among many other things, but the key part for this particular process, shall we say, is looking at that 144 points of light. Of course, anyone using a standard spectra of any brand on the right, yes, you can look at 5 points, 9 points, what have you. It's still very useful, but I think you can see the difference on the left. It does allow us to see a bit more what's going on, but it's a useful thing that we do. One of the things I find, though, as a screen manufacturer, when I'm talking to customers particularly, I think people sometimes struggle of what I call the limitations of laser speckle validation, or any equipment validation for that matter. So if you've got a customer testing, be it your projector, be it your screen, whether it's for speckle, whether it's for any other image quality, whatever it is, I sometimes find that end users don't always understand how to do what I would call a fair controlled trial. It may be, well, I saw your projector in the London cinema and I preferred the other brand projector I saw in the Paris cinema. Was it the same screen size? Was it the same theatre geometry? Oh, well, no. Was it the same movie content? Oh, I don't think so. We had a different film that week. And it's trying to get the end user or integrators to understand when they're trialing things to do it in a fair way, which to me, and that goes either way, it could fall on the bad side of whatever product we're trying to sell or introduce. But we have to allow people to do it on correct screen size, matching light levels, matching theatre geometry, any of these things, so it really is a fair comparison. And that works for me, good for the customer, but it also works great for the manufacturer. If something's not right, we want to know about it. I don't want it to be masked by a favorable auditorium setup. To me, that doesn't help anybody. So one of the things we do is make it clear to people about speckle contrast ratio. Sometimes you get an end user saying, well, what's the speckle contrast ratio? And again, I've got to make it clear to them that it's an internal relative measurement, or in our experience, and it is difficult to correlate to the movie experience. When I showed you those samples and there was a bar chart showing you different samples, just because one of those samples might appear a little bit higher than the other doesn't necessarily correlate to that screen was speckling much more than the one next to it. It might be, but it might not. And again, a lot of these, what I call the sort of visual impact factors, depending how bright it is, how close you are, the shape of the auditorium, et cetera, could all affect that. Also, when we're doing subjective evaluations, we have to understand the limitations of that as well. That's different people's eyes. Some people are wearing eyewear. I mean, I've noticed recently, Goran commented on my cool glasses. Thank you, Goran. But the point is, when you're wearing glasses, mine are now varifocals. And I now notice when I look at speckle, I see it in a more narrower part of the hotspot than I did before I was wearing varifocals. So that's an interesting part as well. So also, when we're looking at screens, one of the points there, I put half and half screen trials are artificial, or they can be. So you have to be careful if you're putting one screen surface almost stitched to another one side by side. If there's a big difference in gain, then you could have one half looking incredibly bright, which your eye is drawn to, very, very different to the lower light level on the other side. So that can be artificial if you're not used to what you're looking for. So particularly if we're working with customers or trade shows, we often move to now, like we did at Cine Europe, we're moving to a one at a time model. So we might have the screen we want to demonstrate as the main screen, and then we might wheel in on a mobile frame the screen we're matching against. It's not ideal, it's not tensioned exactly the same, although it is tensioned, of course, but it allows us to move a different screen in, perhaps adjust light levels if there's a gain difference, and show a fair trial, particularly if you're in a customer auditorium or having a lot of time to do a demonstration. And also an interesting thing, if we're looking for speckle, and unfortunately, because I've looked at speckle for so many years, I can't help but see it. And I do, and it's just one of those things. But sometimes I might not be doing system justice. And I think if you have anybody looking for speckle and you start at the screen with your nose touching it and you walk backwards, any speckle you see, you'll continue to see it for a long, long time as you move back, just because you've seen it and you can't unsee it. So sometimes I think a fairer way of trying to evaluate something, or to start with at least, is start from almost from the back of the auditorium, start walking through or moving through the seating area when you first start to see speckle. And it's just a different way of looking at it. So we're doing a lot of things like that now, but it's not saying one's right and one's wrong, but these are some of our findings, and we're just trying to be honest with the limitations. And again, I think I've already talked about this at the start of this slide: limits of end user understanding, speckle valuations are relative, projector technology expectations. Again, if you've got a RGB projector and you put it on a very high gain screen in a very short auditorium, the front seat is very close to the screen, you're going to get a very different experience to if you had a sensible front seat throw distance and a different shaped auditorium. So to me, when you're talking about laser speckle to anybody, it's not just a projector, it's not just a screen, it's a system. It's a solution you're putting together, and any part of that chain can influence it. So it's not just projector technology expectations, but it's expectations of any part of that system that we have to make sure whoever's evaluating it is understanding. But when I say projector technology expectations, I'm probably more talking about RGB versus laser phosphor versus RB laser. Again, very different projectors, and in my opinion, all have their place. I've seen very good projection of all types, and to me, it's nice to have the spread of different types of laser technology. The screen gain itself is very important. Screen gain has very many plus points, but it also has down points. Again, it's understanding how to best deploy a certain type of screen gain in a certain auditorium and understanding what equipment is being deployed with it. Same with theatre geometry. You might have the best screen technology, the best projector technology, wrong shape auditorium. You might want to change that choice. And again, customers understanding foot Lambert and hotspots. Some customers just, they might see a demo at 14-foot Lamberts of 3D, back in the, not so long ago when we were doing that, or it was one of the things, say, at CinemaCon, they'll come back and try and show their 3D at 14-foot Lamberts with a large projector. But if they haven't got the movie content mastered at those higher levels, they're wondering why it's looking washed out. So again, it's just understanding of what you're trying to do. And the same I put here, hotspots. Hotspots are there, particularly with higher gain screens, but what affects a hotspot? The gain has part of it, the theatre geometry has part of it, eyewear and things. So just useful things trying to get across to a customer, in my experience. And then I mentioned earlier, we just internally, well, not internally, but within Harkness, we where we talk about this sort of methodology of how we put together the lab-based work alongside the field work, and also the knowledge base and understanding we've gained as a team over the years. We call that our perceptor methodology, but it's when we talk to customers about this, we're just trying to let them know that we understand what it is. And I think it's important for all of us, manufacturers, integrators, end users, to try and understand as much as possible of what you're trying to do. And to me, the key thing is that all auditoria are unique. And it's very easy to say, I want to just buy this screen and deploy it in all my auditoria. That isn't necessarily going to work. The same with projectors, the same with 3D systems, and particularly where we're talking laser projectors, because one size doesn't fit all. And I think that's incredibly important. So for us, the output of that, as some of you will have seen, is trying to develop a screen that works for a certain purpose. And for us, we've worked alongside our partners with, looking at things like laser speckle and different screens for many years, and we've had some very, very good results. One of our latest results, we feel, is our Hugo screen, which we launched at CinemaCon, and we've launched in Europe last week at Cine Europe in Barcelona. And this is a polarized 3D screen, but it really is a step game change for us anyway. And what I like about this screen, outstanding 2D and 3D performance. And what I mean by that, it maintains 3D polarization very well. But for me, the 2D performance of this screen is really quite interesting. So just looking at things like brightness uniformity of this screen, and I'll show you some imagery, but it looks a lot closer to a coated white screen, and noticeably so. When I was doing a lot of trials on this screen, I was actually quite blown away by that. When I first saw it against a coated white screen, it was like, wow, really, really impressive. And of course, the speckle reduction technology we built into it, it doesn't completely mitigate speckle, of course it doesn't, but it's a step change from our previous technologies. And this is where it's important. It's not that you completely mitigate the speckle from the projector, you completely mitigate it from the screen, you have a perfect auditorium. It's part of that solution. And I think from a screen basis now with this product, we have moved that a different step, which is great. And to me, again, mention that wider experience. It is particularly on axis. And what I mean by that, when you're looking down the center line, it's almost indistinguishable from a similar gain white coated screen, which is useful. When you move off axis, of course, it's still a silver screen. It doesn't perform quite as well as a white screen, but it's not a hugely noticeable factor. And the other thing we like about this product, which we're very proud of, is the improved contrast of it, which I will also show you. So I will just move on to here. This is a video, actually, which I'll just press play in a moment. It's just taken on my iPhone, so it's nothing that's been professionally produced. It's not been altered. It's in one of our R&D centers, and it's showing a Perlux 1.8 gain screen and the Hugo 2.2 screen on the right. Yes, of course, the Perlux is slightly lower gain, and the Hugo is higher gain. So the Perlux is more favorable, shall we say. But what's interesting on this, and just to be clear, this isn't about laser speckle, it wouldn't be picked up on here, but what I'm talking about is about the brightness uniformity and contrast. And what's useful about that, although you won't be seeing speckle picked up on this type of camera at this sort of distance, in my experience, because speckle is now mostly seen in the hotspot, unless there's something really going wrong, if you can have a more uniform, more broader hotspot or a non-perceivable hotspot, that speckle is so much less perceivable. So that's the point, I guess, I'm trying to get across here. So if I play this video, which hopefully is playing at your end, guys. Is that working? Can you see that, anybody? Yep, I've got a nod there, perfect. So on the left is the Perlux, and on the right is the Hugo screen. Side by side, and I'm filming on axis, it looks pretty much the same. I'm not seeing the 1.8 gain white screen looking suddenly more uniform than the silver screen on the right. But also look at the blacks. So we're noticing here very much that we are seeing those blacker blacks on the right, more so than we did similar trials with, say, a Claris or a Spectral, one of our different technologies. So that's been quite interesting for us as well. So this screen isn't just about laser speckle, but that's one of its key properties. But yeah, that's been very pleasing to see. And this side-by-side screen is a bit more comparable and a bit fairer because it's 1.8 to 2.2. It's not 1.4 versus 2.9 gain. It's not such a huge difference. So yeah, I think that's still running there. Let that one finish. But it's just lovely to see on axis that, 2.2 gain silver screen, no discernible hotspot. And there we go. Nearly done. Perfect. Yeah, that's the one. So, perfect. So for us, it was nice then to, of course, get the output of that. One of the things we did prior to CinemaCon is we took the screen to the studios in the US, and we had that installed in one of their friendly cinemas. And what was good for us, I wasn't present at that particular trial, but what was good for us with the team that were there is they were looking at their content on an RGB projector. So an RGB projector, as we know, will speckle more due to the wavelength diversity compared to a laser phosphor and RB phosphor. So it was on an RGB. Comments there were reduced speckle, and they picked up the contrast improvements. And apparently we even had an audible whoop from one of the guys when he was seeing his content on the screen, which was quite cool. So that was nice to get that feedback and not get any negative or just neutral feedback. They did see the difference, so that was very pleasing for us. We've obviously had cinema trials, as I talked of stage 4 of that process, where we're taking the screens out into the field. And again, we've not just shown it on our RGB, we've shown it on RB laser phosphor as well. And it's been really good to see comments on their RB laser phosphor, the speckle on that from there, things like it's similar to the speckle you might get, or the twinkling you might get from a xenon-based projector. So that was very positive. On an RGB one, yes, it's going to still be there, but again, take into account deploying it correctly with those visual impact factors. If you've got the sensible distances and things, it was very much reduced. And I think one of the terms I talk about when I'm looking at speckle is soft or coarse speckle. So for me, when I'm looking at, or to my eye anyway, bad speckle, I'm seeing very harsh, very large pieces of speckle, use a crude term. But what we're finding with the Hugo screen particularly is when we're looking at it, the speckle is reduced because it seems softer, it's less harsh. And that's been a really interesting output. We're very pleased with that. Light distribution, as I've shown you on that previous movie, is favorable. And again, we've had customers actually saying, what, this is really a 2.2 gain silver screen. Yeah, it's not a 1.7, lower gain Claris or something. So that's been very interesting. And of course, most recently at trade shows. So we've had a lot of customers at our trade show booths at CinemaCon and at Cine Europe. And again, really useful. When we trialed it, again, I was at the Barcelona one. We were trying it with a projector. It was a much larger projector. So some of the laser modules had to be turned off to bring the brightness down. So it was unfavorable conditions, less wavelength diversity because some of the modules are switched off. So there was absolutely noticeable speckle. But again, we were bringing in an existing silver screen in front of it of a similar gain. And that screen brought in, you could see that difference. The screen was of a higher gain we brought in, but still you were seeing that difference, the softness, this difference, which was great. And also we had a lot of customer comments on the contrast itself because we were showing movie content as well, different types, both 2D and 3D. So that, again, we were very pleased to get that sort of independent feedback. So that's actually my last slide, and I appreciate I've talked for quite a while. I don't know if I'm within time slot, Bill, but hopefully that was of some interest to people. And absolutely, as Bill said, open to any questions. I'll do my best to answer.
Well, thank you, Matt. That was high-speed data transfer, and we all appreciate that because we're all busy folks. I'm going to kick off the Q&A session with kind of a general question, which will allow you to kind of branch out, and then we'll take questions from the audience.
Sure.
How did Harkness decide that laser illuminated projectors could benefit from a screen specifically designed for lasers? And are these screens for cinema only?
Yeah, good question. In principle, the screens that we're deploying are the ones I've been talking about are cinema screens. That said, we do screens for event markets. In my experience, and I'm not the events guy, we do have guys that work specifically for that in Harkness, but in my experience, speckle seems to be less of an issue in the non-cinema market because you're not looking at trying to adhere to standards, DCI, what have you. You haven't got people looking at image quality so acutely as you quite rightly need to do with a movie. And I think in non-cinema markets, certainly projection markets, I've not heard that there is an issue with speckle. So the screens absolutely can work in those markets, and it might be that those markets say, well, absolutely, yeah, we see speckle, it's not an issue, but would we be interested in something that has less speckle? Maybe so. So in theory, yes, they absolutely can. But from a Harkness perspective, of course, it's come from cinema. So you could argue our screens, if we talk be those matte white screens, uncoated PVC, or if we talk about Perlac screens, coated white screens, or we talk silver screens for 3D polarization maintaining, any of these screens, when you project on it, they will essentially reflect back or react to whatever's projecting on it. So the screens were there already, then the laser projectors came about. So it's in our interests because speckle suddenly became a thing. And particularly in the early days, it was a big problem, much less now. So from our point of view, to keep pushing the boundaries from our side was very important. And as I say, when I talk earlier about it being a system, a solution, shall we say, with different components, it's great to see the projector manufacturers making leaps and bounds in speckle mitigation. People understanding it, we see screen shakers in certain situations. Again, make a huge difference. But from our point of view, we need to be part of that, because our customers are always coming to us and saying, look, I've got a challenging environment, you know, I might have closer projection, what have you. And again, they're asking us, what are you going to do? When's the next one coming out? And it's something we're obviously always working on. It's very much in our interest. So I think it's to be part of that solution where we can't be blinkered and say, oh, it's not a screen problem. You know, it's when we are talking Speckle, it's part of a chain. Oh, you're muted, Bill, I think.
Open the floor to questions. I've got a few more, but in fairness to the audience, fire away.
I have a question.
Yeah.
Hi, Goran.
Hi. So Matt, I remember, well, a few years ago, it's been a while back since I left the cinema market, and even before COVID, I think we in Barco did some tests with a speckle contrast measurement and different screen types and projector types and so on. And what we saw is that if you would have the same conditions and the same projector and the same measurement systems, and then you put two screen makes, you know, like different types of manufacturing, maybe different manufacturers and so on, we could find a situation that we measure the same speckle contrast, you know, very similar speckle contrast on the two screens, and then you put content or even a white test pattern, and then your eye will tell you a different story.
Yes,
So that your eye will
totally,
say,
yeah.
no, the speckle contrast. So we were talking about the same conditions, right? Same illumination level, same distance from the screen, same projector, same white test pattern, and still same speckle contrast measurement, and your eye says, nah, it's different. So
yeah, absolutely.
Maybe, so following your speech, maybe it has to do because of the hotspot size and so on and so on. But my question to you is, have you found a variable or variables? You don't have to tell me, you know, it's manufacturer secrets, but have you found something in your mixtures and processes that explains this difference, to say, yeah, indeed, this is what makes speckle worse, even though you measure the same speckle contrast?
So to me, it's these what I call visual impact factors, which, so if we're looking at a contrast ratio measurement, whether you're in a lab, whether you very accurately set it up in a cinema, and that's very difficult to do, but it can be done. You could set it up exactly. Still, it's a camera looking at a sample, taking a photo, picking out what that speckle is and making a ratio of that to see how much speckle is essentially being reflected back from that sample. But again, what that doesn't take into account, in my experience, is it won't take into account brightness levels. So if you're doing a speckle contrast ratio, you could double the light output and you'll still get the same brightness ratio.
Yeah, but all things the same, brightness levels, distance from the screen size, everything the same, and then still people would perceive a different speckle at the standardized distance.
Yeah,
and we never understood that. And to me, just shows that there is, so the speckle contrast measurement is only one part of the story. It does not tell you the entire story, even in standardized, and there's still something more. So maybe there's still a different quality to the speckle, which the measurement does not describe in a way.
Absolutely, yeah. And I think using the part I mentioned about the glasses or people's eyes, I mean, people's eyes are all different. I would like to argue, certainly from the type of cinema techs I work with yourself, if we both looked at an example of a combination of screen projector theatre, we would probably both agree that this looks like really good acceptable speckle or not discernible, and we'd probably both agree that that looks really bad, for example. But we'd still be seeing it slightly differently. And I think, again, I'm not one of the scientists at Harkness, of course, but of course the eye will see very different to a camera. As another thing, the camera is literally picking up, but it's not interpreting it as the eye would. But to me, then, the speckle contrast ratio is taking that measurement as it's measuring it straight in front of it, but it doesn't take into account, as you said, hotspot, brightness uniformity, because it's how you perceive it over the whole screen rather than a very useful indication over a smaller sample. So I think that's my takeaway. It's
Okay.
it has to be
I
done
have
in combination. There's
yeah,
more to learn.
I have one more question before
Please.
I mute.
Yeah, we have
I'm not
time.
sure if you know that the answer to this question, but you speak about the speckle contrast ratio, but there is also the speckle grain size, which I think we never really investigated properly. So when you said, on some certain screen samples, the speckle is softer,
Yes.
it makes me think of the grain size. So have you found a way to measure the grain size and to link it to speckle perception?
Yeah. Of yet we haven't. We
Okay.
measure
Yeah.
speckle, but we're looking at it and I
The
know how
contrast.
you guys do it, very similar ways to you guys do it at the
Yeah.
moment. But I do
Yeah.
think there's probably there probably is something in there, because certainly
Yeah.
the eye captures it that way, but it still won't be
Mm.
probably the same grain size as you do in a photographic contrast measurement. But
Yeah.
there will be a difference, but we
Yeah.
haven't got a correlation of that yet.
No. No. I
But there is
understand.
something.
We also couldn't
Yeah.
find it, and
No,
it's a
no, no,
tough.
absolutely. And it is, and I haven't found anyone that has yet. It is so
Yeah.
difficult to correlate. But I think, if we look at, use your term of grain size, which is a nice way of putting it. If I think back to, and you'll probably remember as well, the very early, really early 3P first laser projectors, the grain size was huge. So
Yeah.
it was the coarseness of that grain, but it was also the spread of the grain. That was my take. It
Mm.
covered the whole screen,
Mm.
more prominent in
Mm.
any
Mm.
hotspot areas, but
Mm.
it literally covered the whole screen. It was really distracting. But now it's grain size, but within the hotspot area is my experience.
Yeah. Okay. Thank you.
No, thanks, Goran.
Any other questions on that topic or different topics? Well, I've got a variation on that one, Matt,
Please, Bill.
and I'll see if I can frame it clearly enough for you and the audience to think about. If you have three projectors all set up and looking at the same screen, it's likely that you'll get different speckle contrast ratios, call them good, better, best, for that one screen, for that one setup, geometry, et cetera, all these other conditions. If you then take those three projectors and test them with different screens, will the relative position of good, better, best stay the same no matter what the screen design is? In other words, does the projector have a level of speckle itself, and then whatever the screen does to it, does that follow, at least qualitatively, the good, better, best measurement of the three projectors?
Understood, Phil. So from my perspective as a screen manufacturer, we obviously approach it the other way. We might be having a particular projector model, and we'll bring in various screen samples and types and see what's going on. But anecdotally, I'm pretty sure I haven't got a data set to give you, but anecdotally, to me, yes, absolutely, different projector models when I see them in different locations. And I appreciate that's my subjective opinion based on experience, and it's not foolproof, of course. I could see different models and go, well, yeah, actually, yeah, I've seen that at multiple locations, and that's speckling more than I might expect in this type of geometry with this type of screen surface. So I would imagine, I haven't done it myself, but I would imagine if you got those three example projectors and you took them all into a lab and did a speckle contrast ratio with fixed samples, I imagine the contrast ratio would correlate at least to one's better, one's middle, one's worse, or whatever we did see there. I would believe, because essentially the screen and the geometry or whatever can only reflect back with any changes it does due to gain and what have you from what's been put into it from a particular projector or laser light source.
Mm. On the experience that we have had is we would use one screen and then have several types of projectors, or disable lasers or wavelengths and so on, just to test speckle. And indeed, when you have one screen and several projectors with different speckle contrasts, then the ones with more speckle contrast will also visually, you have a higher, you will perceive more speckle. So you can draw a line, measure speckle contrast, and indeed you perceive more speckle on a different projector or light source or whatever on one screen. But then, as I mentioned earlier, you have one projector and put it on two different screens, and you measure the same speckle contrast, and still your speckle perception is different. Then when you start changing the screen types, you cannot put a draw line anymore. You cannot say the speckle perception is linked to the speckle contrast you measured, because then you have a bit of you've changed something that impacts visual perception, but it's not really measurable in this way. So then I would imagine that if you have a different projector mix and then you put them on a different on different screen, then you really cannot tell. You can measure something, but then indeed you have to do what Harkness is doing to have more in-depth investigation into how the speckle is really perceived rather than just measure it. So it's a complex thing.
As we're getting close to the end of the session here, I'd like to ask a general question of really Matt and everybody. Are we, in terms of where we are in the history of laser projection, are audiences and exhibitors and creatives getting more demanding? Or, I mean, for a long time, it seemed to me that speckle really wasn't a problem anymore. But now there seems to be maybe a little bit of interest in it again. So what's the status in the industry of, speckle, just sort of based on running around trade shows and talking to people?
So my viewpoint, I guess in my experience, would be, yes, people are talking about speckle more. And I think as things have progressed, it's also part of it is, to me, is the progression of speckle mitigation from the projector manufacturers plays a part of it. But it's not that simple. It's also depending who you're talking to, because you could have if I imagine exhibitor conversations, you could have an exhibitor that just doesn't care about speckle. It might be present. You or I might walk in there and really not like it. They might put the highest gain screen possible in to save money, trying to achieve a certain peak brightness, not doing it in a controlled way, shall I say. That can happen. And that it might be in a situation, geometry is not right, all the things aren't right, but it's cost effective for them. That is one model of customer. Another customer will care deeply about having everything right, etc. But for me, I think why speckle came back more on the radar, if I go, early days of 3P, speckle was quite bad. We then had things like flagship 6P, and the speckle mitigation was very good, really went, was a real step change improvement. The same as, for example, say the 9P versions from other manufacturers. Again, speckle mitigation was incredibly good, even on higher gain silver screens. Of course, then when we move to direct 3P projectors, which have a lot of advantages, but certainly, let's say some of the initial models, I think the speckle was a backward step and it came back on people's radars. Again, my experience now with a lot of those direct RGB lasers is I think the manufacturers are doing a good job at bringing the speckle levels back down again, which is great to see because it is all part of that system. But I think perhaps that blip of direct RGB brought it back to the forefront is my experience.
Yeah, if I can add to that.
Oh, good.
Hey, nice to see you.
Well, I'm not sure what category Matt puts me in of those exhibitors. So,
well balanced.
Let me just. So I think, well, the new laser projectors, or the direct 3D laser projectors that came about a few years back, did bring Speckle back on the radar. And in my previous job at Nordisk, we had some, what should we say, very bad experiences, and also did a test with Johan and Matt, I believe, in Norway. The projectors, at least in my opinion, has improved a lot. So Speckle is under control, especially when you go away from the pure silver screens, etc. So 1.4 gain or 1.8 gain wide screens is very acceptable, especially 1.4. I think one of the things that brought it on for us is that with less and less 3D content, we are showing more and more 2D content on the silver screens, which sort of brings it up again. So accepting Speckle on a 3D silver screen was sort of, well, we have to do it because we want to show 3D. But when running 3D only 5% of the time, we are sort of exposing 95% of our audience to excess Speckle. So I think it's very interesting what we're doing. I think also that having a Speckle-friendly, high-gain 2D screen in the future would be good. Because we do have cases where we need to have a 1.8 or 2.2 gain screen for non-3D purposes, simply to have enough light on the very big screens. So if that's the way it goes, it would be good.
A well-researched perspective there, Jan. We can keep going if you can, Matt. I mean, I'm good. I mean, you and I can talk till the cows come home, but
yeah, I'm the same.
But I really want to give opportunity to other people on the call, because this not only Matt and his presentation, but you've got some people that have spent a lot of time thinking about this, and we have an old friend of mine, Barrett Lippy. Barrett, could you talk about any kind of special case questions that pertain to high dynamic range?
Well, thank you for giving me the opportunity, Bill, and nice to see you again. But unfortunately, the work that I've done at Dolby is all proprietary to Dolby.
Well, then don't talk about it.
And the work that I've done with Harkness is covered under the NDA with Harkness. So yeah, I don't think I can actually say anything, unfortunately. I would love to, as you know.
Well, then I'll pop this back to Matt for everybody's benefit, and he can say whatever he can say. You did say several times that the absolute brightness on the screen as a first order effect is very important. And of course, angle and seating position and so forth come into play. But as we move from the 14-foot Lambert world to the more than 14-foot Lambert world, with either proprietary high dynamic range systems or with maybe a industry standard evolution of a higher dynamic range system. What can you tell us qualitatively? You know, I'll just throw out you know, if you crank it up to 20-foot Lamberts, is it just a given that you're going to see more Speckle, and therefore we got to do more work in the projector and in the screen and in the system to mitigate that? Is that a general conclusion?
Yeah, I mean, things, of course, vary on projectors and other factors, but in principle, yes, in my experience, just even, you know, standard cinema, if the brightness level goes up, that is absolutely an impact factor. again, depending on the content you're doing, it makes a huge difference. But use your my Lawrence of Arabia example. If you might have acceptable speckle and you put the brightness level up, it's going to be a perception factor for someone, definitely.
And a similar question though, but from a different angle, if we evolve toward wide color gamut and where we get both higher saturations in the color gamut and higher volumes, that is higher brightness at saturations, do you think that will impact speckle in a qualitative sense?
Yeah, I'm not sure, because that's not in my experience, Bill, to be fair. I'm not sure.
Anybody want to hazard a guess on that one? Well, we'll have to see whether that will become, as we improve image capability, let's say, either whether it's brightness or color gamut or color volume, other things change. And so I think this basic topic of continuing to mitigate and minimize any objectionable speckle we're not done yet. And I think that's a great, we're over time, but I think that's a great place to close. There's still room for innovation. There's still room for tests and experimental design. And we've got the people. Oh, Eric. Oh, I thought you were raising. Are you raising your hand or?
Oh no,
I don't
no,
know what that means.
it was just a clapping reaction. I was just saying thanks. Yeah.
Okay. Well.
No, but great
all right,
presentation.
well,
Thanks,
well,
Matt.
Let's give Matt a hand and let's keep thinking about this.
No, thank you all. It's been good.
Thank you so much, Matt.
Okay. Thank you.
Thank you.
Take care.